scripting. Here we go.
Hello, everyone. Welcome on Thursday, December 7th, 2023. Tonight, we have a webinar called Improving Technology Procurement and Reducing Risk. And tonight will be three presenters, Dale Brown from Hatch, William Gleckler from the MTA, and William Huey from TransLink. I'll give you a quick bio of each one. But Dale is a Director of Systems Engineering at Hatch. Dale has acquired expertise in embedded control of specialty equipment, mining, heavy construction, military, and rail vehicles throughout the U.S., Canada, South America, and Europe. He is a licensed professional engineer, and with extensive design management, business development experience, he has been awarded patents in the areas of PTC, train control, and constant train line communications. He has recent experience that includes BART, LIRR, MARTA, NYCT, Ottawa, SLE, and a various long other list of accomplishments. He's co-chair with the INCOSE Transportation Working Group and co-chair of the INCOSE Configuration Management Working Group. And Bill Gleckler, who's a principal systems engineer at MTA. Bill is TWG director at large and provides mentoring and advice to INCOSE Transportation Working Group membership. He is a principal systems engineer for MTA in construction and development business unit. After 8 years in the design and manufacture of products and systems used in automotive, defense, and space industries. So he's been at this for quite a while, particularly at MTA and NYCT. For Bill Huey, he's Director of Systems Engineering at TransLink. William is Director of Systems Engineering at TransLink in Vancouver, Canada, and has been with the organization for 16 years. As an engineering graduate from the University of British Columbia, he leads a team of project managers and engineers delivering capital products for SkyTrain that involve technology integration, supporting both state of good repair and rail expansion, such as Broadway Subway and Surrey Langley SkyTrain. So his work includes the delivery of Compass Card and Farragut project, as well as the implementation of the Evergreen extension. So with that, I'll let those three gentlemen begin their presentation for tonight, and we can allow them to present and then ask questions at the end of the session. Dale, William, the floor is yours.
Thanks, Mike. Is the screen big enough, or should I go to full slideshow mode? That's just a general question to those out there looking at it.
I think if you go to full slideshow, it'll make it better.
All right. Yeah. Slideshow from beginning. Okay, here we go. Thanks for that intro, Bill. So, Mike. Hey, we're both having trouble today. It almost seems like Friday. So yeah, we don't need the safety briefing. We're not signing in. So the agenda is I'm going to try to go through I will go through the SLE standard framework and the front end of that in particular, which addresses the procurement of technology. We'll probably hold all the questions till the end, I think, Mike. And also we can capture questions on the and Mike will be watching for them since we can't see the chat. So and then William will go through some case studies from TransLink, and same thing with Bill from MTA. So off we go, and so just kicking it off. So life cycles has life cycle process engineers, if you will, just taking the subtitle of both the INCOSE handbook and the international standard. We're obviously concerned and thinking about assets and projects from cradle to grave. And, we're looking for considerations of all the ilities and all of the functionality, throughout that entire life cycle. And to accomplish that, we're also concerned with triggering the right interactions between stakeholders at the various points in the life cycle. So we're concerned with the breadth and also the depth, the knowledge and the time the knowledge just distributed across the time at convenient points. So, there's basic transit and rail life cycles. I won't go through them all. You can sort of make up your own. There's a very good standard life cycle, which is the one at the very top here, which is actually represented by a separate ISO standard, 24748, I think, where, you have a concept, you develop it, you produce it, you use it, support it, and then you either retire it or rehab it. That's pretty universal. And then, there's all the very specific ones for each industry. And this is right out of the handbook. So you can see that on your own. So oh yeah, it is 24748. So here's the basic one. And the concept is there's control gates. Not all gates are milestones, but each milestone should be corresponding to a control gate, if that's how you're trying to get the risk mitigation as you move along, corresponding to the money you're paying out. And then you can only, in theory, pass into the next stage if the agreed requirements for that stage have been achieved. That is easier on paper than in practice. And if there's no oversight of that, you do effectively lose control of the project, because those are called control gates for a reason. And if you're basically disrespecting those gates, then you're no longer in control. You're just running an ad hoc project that's rolling along like excuse me, like a steamroller. So a lot of infrastructure projects we found really start kind of there, somewhere in development. We don't get a lot of stuff done early enough in the concept, which is one of the whole points of why our APTA SLE standard is going to focus on that first up to that first gate. So you see these characteristics. It's the same as last project, not a big deal. We ask for the crazy, number of planning documents. And often we ask for them from the supplier, which is one of the first things we're going to try to correct in our new standard. And we ask for them at NTP plus 30 if we're generous, NTP plus 60, but that just becomes shelfware. And by that time, there's already deliverables coming in the front door. And of course, with all that happening, you're rarely getting decent system requirements, or if you get any, and you don't have that sort of iteration between system requirements and architecture, iterating around to find the optimum architecture and to inform system requirements of changes, new system requirements. So all of that's supposed to be iterative. So that often gets left behind. And then one of the worst sins is all the really foundational tools. And by tools, I really mean, the processes and whatever supporting electronic tools. Yeah, but if you don't have those foundational processes up and running, and that means people are trained on them, everybody has access that's allowed to have access, then that's a real problem, because you're really starting. It's almost like starting a new company and you're expected to deliver something, and yet you don't have any of the tools set up in your company to make that happen. So people resort to whatever ad hoc methods they have to, because most people enter into these things in good faith, and they're trying to do a good job and make the world a better place. At least that's my belief. So we want to really focus on the early life cycle activities. And you can see, even just from the INCOSE table, there's, could everybody mute? There's something coming through in the background. I don't know if you can. Oh, thanks. Yeah. So in these early concept, tasks, very, very little of this gets done well, if it's done at all. And that's why we pointed that other arrow, to sort of part way through the development phase. So that's a significant number of project activities, but the bottom line is they're pre-design. There was never much money allocated to them. And they're also, quite frankly, less interesting to a lot of designers, especially younger designers that really just want to do cool things. And this stuff is kind of processy and a little bit boring. So, and I took this, I only discovered this about a year or so ago, and I thought it was fascinating. And INCOSE worded it so well, so nicely, where they say, eager project champions who want to get on with it. And that's really a nice way to put it. But they do succumb to the temptation to just let's move ahead. And sometimes they blow through project gates out of that eagerness. And that's what we're trying to prevent from happening. So the whole point of my little bit of the thing, and I got this from Lou, who runs some really great requirements, needs and requirements workshops, and is one of the key, I think the founder of the requirements working group at INCOSE, and also has produced a lot of great publications for writing better needs and requirements. And his main thing is this idea of accruing technical debt across the life cycle. You can pay it early, or you can pay it at it 200 times. Or I've even seen numbers now where that 200 that we used to use all the time is now up to 1,000 times cost later. So that's something to think about. So here again is that life cycle, that a TR24748 generic life cycle, and you can evolve this into whatever your project needs. But the idea is that you've got all this concept work that that needs to get done, and hopefully done well, before you get into the development segment. And having said that, there's a realization that there's separate sort of flows that happen, because you've got different sort of flow rates for things like civil and architectural versus, say a train control software supplier versus a signaling designer that's brought into the project, versus the electrical, like the traction power folks. They've all got their own life cycle that's similar to this, but the timings vary quite differently. So the key is to figure out how to integrate that, and that's a separate topic. So we won't go any further into that. So this is kind of the proposed life cycle that we're looking at in the APTA group, and we're kind of focusing on even more than mobilization, but we're focusing on these three early life cycle phases. So we're using, of course, the baseline from 24748. This is the prototype, and there'll be a set of requirements for each of those gates, and you can call the gates whatever you want. This is what we're proposing. And you'll also notice we changed this from 30, 60, 90 to 50, 80, 100. I mean, the goal should not be that, at the end of so-called final design, you still have 10% of the design to do. That shouldn't be the goal. So you probably shouldn't call it 90. I know we've done it for 30, 40, 50 years, 30, 60, 90. Everybody's used to that. I think we need to adjust our thinking on that. That's just our opinion. But so that's also going to, this is the framework for the discussion today, and really going to focus on those first early technology procurement aspects of this whole thing. So there they are: business planning, project planning, procurement, mobilization. So business planning is where you're really reaching back into the agency or the railroad and figuring out what really needs to happen. And they've got a pot of money to spend, or maybe they're asking for money. If you reach far enough back and you can support them as systems engineers in that business planning phase, project planning is super critical. And that's I think it's just flat out broken, because we just reiterate the same broken approach that project after project after project. Procurement is the same problem, and there is now a technology procurement working group. If you're interested at APTA, please consider joining us, because it's not just engineers that are involved in this discussion. It's actual procurement officers, folks from legal. So there's a lot of good stakeholder involvement and there's a lot of interest in fixing procurement, because I think the consensus is it is broken. You can't just keep repeating what you've been doing and expect a different result. And then, of course, mobilization, less focus on that. That's more straightforward. So, and I think, I mentioned that. Yeah, I'm going to step it along here because I don't want to run out of time. So for instance, the business planning gate, if there was such a thing, you want the stakeholders figured out, who are they, which ones are going to be good contributors, which ones are probably going to be blockers, maybe for political reasons. I mean, politics is just a fact of life anywhere you go. So you have to, and yet, so that's sort of the stakeholder management part, but the engagement part is quite different. We'll get into that in a second. Oh yeah, little note, and just in case there's INCOSE folks like Lou see this. Yes, this is a very compound requirement. I apologize for that. It's just real estate on the slide and timing. So again, another compound requirement, and there would actually be proper well-formed requirement statements written around what is expected at this first gate. So the mission goals and objectives, you need to set up what's your risk and scoring formula. And aligned with that is sort of what's the priority that you all agree on for this project. It's tied into mission goals and objectives. And that way you can use that same priority scheme when you're putting priorities aside, assigning them to actual requirements, system requirements, which is a best practice according to the 29148 standard for writing requirements. It's also in the requirements working group material. So that was the sort of the business planning phase. And even within that, you can have some subgates. I took this concept actually from manufacturing, who have to do a lot of research before they decide they're going to do a new product line. So this is from something I was working on with General Motors. So you have that upfront brainstorming, and that's where you figure out, the SWOT analysis. What are the mega trends around the world, or at least in your community? Worst case, at least within, North America or your part of Europe or Australia. What's happening as a mega trend in that area? What are people looking for? How will people be rewarded for performance? So you need to be aware of that, and that will impact how how you do your brainstorming and gather the information. Then, as we mentioned earlier, figure out your stakeholders, get some initial timing, start collecting your needs statements from those stakeholders. What are the features and benefits analysis going to be? Never a bad time to start the risk register. Earlier is better, always. So that's kind of, you take from the brainstorming, you do a reduction on those brainstorming, and you end up with some ideas. And then you have to put some concept business cases together, and just at a very high level, maybe a life cycle cost analysis, because then you need to take these candidate projects to the board of directors or whoever. And then from all of that, you end up with your capital program for the year, which is hopefully highly defensible and, makes sense. And it captures the needs of the agency. So I won't get into this. I think everybody on this call knows what a stakeholder is, and we are recording this, so you can check it out. But you're either involved in the work or affected by the outcome. And don't forget about suppliers; they are key stakeholders. So this is one view of all the various stakeholders. You can see suppliers is in there. And there's other folks that sometimes get left out besides all the usual disciplines. There's like platform and station agents, operators sometimes get left out. I think that's less prominent now, at least I hope it is. But that was always one that was left out. And the maintainers, of course, used to always be left out. I hope they're not anymore, but I always keep them in mind from the entire life cycle view. And yeah, so this whole idea of stakeholder management engagement, I mean, you can't really get a successful project if you don't engage them early, and if you don't, if they don't feel like they're part of it. It's really an emotional aspect of this whole thing. So and that's how you get your needs and requirements, and find out if there's design constraints. There may be things you want to do that you just can't do. And you won't know that if you don't talk to all of the stakeholders. So I think this there. I'm just going to minimize that. So yeah, I mentioned the emotional commitment, which is pathos. If they're not involved early, they won't feel engaged. And even if the project succeeds technically, it might still fail because it's in the eye of the stakeholders. The stakeholders, of course, includes the traveling public. So if you've not engaged them properly, you could be in trouble. Yeah, so that's the point of this slide, the way people perceive and react to the project. And I think that comes pretty much right out of PMI, as I recall. So motivation, people are responded as to how they're rewarded. So here's a case study for a train display design. So the manager may be primarily rewarded for cost and schedule, not for, fantastic ergonomic design. The operations person is looking for really good ergonomic design because they may not want the drivers union to walk out on them. QA activity would ideally balance, the tension between those, and that's sort of where the systems engineer comes in too. And the technical lead helps by facilitating trade-offs and having those discussions, risk-based decision-making discussions. So don't underestimate the difficulty of engaging stakeholders, especially if they haven't traditionally been engaged in previous projects. Um, and there are some startling statistics on this. Gallup has been studying employee engagement as an analogy for years, and there's a huge chunk of people, like when you look at 41% that could actually be disruptive, that's something to get your attention, or sorry, 41 people. And you might end up, with 124 of those people just not participating or being very passive. And you've really only got 85 that are positively engaged and really trying to make the project work. So, so this was, then this is where those numbers came from, where you've got 85 stakeholders being positively engaged, and 41 could be potentially throwing monkey wrenches into the thing. So that's not great. But people are people, and usually the technology is a lot easier to solve than the people part of it. Um, so there's lots of methods to engage. Not all people are good at, or adept at reading and providing written specs and requirements. Non-technical stakeholders will probably need a lot of visual aids, possibly even rapid prototype models, whether software or actual hardware type models. And maintenance staff may prefer to just be shadowed. So that's another way to, do stakeholder engagement. And sometimes that leads to really, really good information you might never get out of them otherwise. And we sort of, mentioned that up above. If you're going to do a GUI, that's a huge, huge issue. And try before you buy is really a good way to get people thinking about that. So we talked about mission goals and objectives. I'm going to speed it up a little bit here, just bearing in mind the time. Um, so where, you've got a mission, and that's usually decided by the board of directors, sometimes with additional help from consultants. Then the agency has goals to meet the mission, and the goals aren't time bound, but then you end up hopefully with objectives that help you meet those goals, and those should be time bound. So that's a really good way to kind of see the hierarchy. And then out of all of this, for individual projects, you end up with user needs, which again, if we're continuing down the left side of the V, if you consider this part of the very early V, you end up with stakeholder requirements and then system requirements. And this approach of just, initiating projects from one silo just isn't really very defensible, and it doesn't work. As you're thinking in terms of prioritization, there's all the ilities. There's like 40, whatever there is, 9 of them or something in there. Those are all things to kind of just tweak your, it's a good mnemonic. You're not going to memorize all these, but it's good to have something like this to refer to as you're going through and developing needs and requirements, or it can be used to trigger something in the mind of a stakeholder. And then out of all that, you can end up with some of the, how are you going to score your work? How are you going to make a prioritization on the project, or in this case, the capital program? When that's all done, you can do a bunch of multi-voting, and things get sorted and organized. And then you can even get into sort of a threshold matrix using some QFD tools to end up with a very defensible sort of a scoring regime. And then you can also take that into the risk area and say, okay, well, we're going to have to give different scrutiny to the things in the yellow for obvious reasons, and something that say scored 500 in the risk, you're really going to be looking at that very closely before you throw money into it. Here's something, and I don't know if Dave's on the call, but here's something we started at MARTA, which did all of that in a massive tool. And it was actually a sanity check against the CIP for the projects, and it was sanity checking against another AI-based decision support tool to make sure that the algorithm was doing what everybody thought it should be doing. So that was useful, and so you end up with hopefully a designed and defensible capital program that you can then slice and dice into your projects. And that was I mentioned that earlier, practical application for AI. So basically do your homework, be prepared. Observations and trend project planning, there's usually a lack of a ConOps. If there is one, you're lucky. Operation scenarios are usually pretty thin, and maybe they didn't get all the stakeholders involved in that, so you don't really have good ops scenarios. Project goals and objectives maybe not even defined. They just, they're solution based. So we're going to go do this solution thing, but they haven't looked at the bigger system of systems view of the world to figure out, is that even are you solving the right problem? And the timescales are not well defined or budget. There's no budget in a lot of cases for designing a project. We just tend to repeat what we did last time as far as the so-called design of the project goes. We're trying to fix that with the standard a little bit. And so things like configuration management, document control, all these plans are often neglected as part of the process enabling works. And if the foundation's cracked, you know what the results are. Things, it falls apart. So key requirements for the project design gate could be the processes are harmonized based on a standard framework from APTA. Um, and then the processes would be provided to the suppliers by the acquirer, not the other way around. And there's good reasons for that, which we can get into in a later conversations. And then bid scores will include audited conformance to those processes that were provided to the supplier by the acquirer. And that's a defensible audit, and it would stand up well to protect the agency. Tools and training packages should be prepared and ready for deployment before you advance out of the design gate for the project. And using this org chart thing, we're going to show that real briefly in a second, so I won't go into it here. And the org chart, you really need to get the role descriptions and propose the RACI. Oh, there's an A missing, sorry. And those roles, ideally, we would use one of our additional organizations, Society for Human Resources Management, maybe as an outside auditor to take a look at anything that we propose for this APTA standard with respect to role descriptions and how do HR people look at it, because HR people are an important stakeholder. And the idea is we incorporate a balanced QA, PMO, engineering sort of tension approach, those three legs of that stool. Again, I put my compound requirements notice at the bottom because I'm paranoid. So this is just sort of showing a quick view of the idea of planning a project. And again, this is really critical if you're procuring complex technology, but it's also useful. You can scale it down and tailor it down for less complex procurements. But if you're doing something like a train control system or a new tunnel ventilation system or anything that's got a lot of complex technology and interfaces in it, you really do want to consider this more formalized approach. So we have a stakeholder management plan. We've got all these things that are either in the library, and you can see the blue indicates that, okay, that's already in the library. We don't need to reinvent that. We may need to tweak what's already in the library as far as the stakeholder management approach. You've got an initial work breakdown structure. You've probably got an initial Gantt that you can build on in the library. And really, this whole thing is about reuse. It's as much reuse as possible, which is promoting, if you want to use this term, process reliability and really process reliability growth. Because the more you use a process, the more you work the bugs out of it, the more you can rely on it with some level of assurance, which the whole thing is about assurance. And so I won't go through the whole list, but you can you get the picture. So here's this balanced organizational design. I got to move this up out of the way. I don't know if you can see it on the screen, but just in case. So you have to have a conflict resolution path because, as we mentioned in an earlier slide, QA have one viewpoint. PMO is looking for, execution of schedule and budget. Engineering is looking for fantastic solutions, optimal, meeting the requirements. Finance is looking for ways to reduce the cost and to keep control of the cost. Those are, fairly simplified versions of what they're all looking for, but that's it in a nutshell. And if you get an imbalance in this, then you get conflicts that don't work. And here are some examples where for instance, and this is fairly traditional, unfortunately, where you've got sometimes you've got engineering decisions being made by the PMO, and even worse, you've got overriding decisions being made by the PMO against quality. That should never happen. It doesn't happen in ISO 9001 organizations. And if you're seeing it happening in your project organization, there's a big problem there because quality will never, they'll never be heard. This is even worse, where you've got everybody reporting to financial. So there's going to be decisions made there that are not optimal for either project management, engineering, or quality. So that's not good. And there are there's some standards out there that defend things that, like, safety and security shall report to senior leadership. And of course, ISO 9001, same thing for QA. So there's defensible discussions you can have for realigning the organizational structure. Here's a proposed approach. It's just a straw man version of this, where QA reports dotted line directly up to the very senior client level program executive, but they have a solid line to, if it's a JV, the board level. The ISA, of course, the independent safety, is directly solid line up to the executive, and so on. So you're creating these situations where you're trying to reduce the option, or the what's the word I'm looking for? The ability for a conflict of interest, and that's kind of one version of it. Just something to keep in mind as you're thinking about putting a project organization together. Think about the tension between engineering, QA, and project management, and of course financial. Oh yeah, so this is just this is the subliminal advertising that repeats every so many slides. Avoid technical debt. Pay now or pay a lot more later. So you're going to see that. So procurement gate, similar to the other two gates. So early supplier engagement is one approach. It's an active versus the passive approach that seems to be used today in a lot of cases. An independent third-party auditor could be deployed out to, say, the top three supplier candidates. And suppliers are audited against agency process plans, and they can also be audited against what they claim to be their internal processes. Like if they claim they're ISO 9001, okay, well, spend a few bucks and find out if they really are, or are they just a branch division of a parent company in some other country, and the parent has the ISO 9001. This is just one example, but the branch organization that is the actual supplier of goods and services doesn't have it, and therefore doesn't meet the needs. So these are things that we're proposing, and we'll see how they fly. But this is a technical procurement, design is the intent of this. So we have to do something to make to really increase accountability across the life cycle. And we can do a lot of things to improve the precision of the response to requirements. And then you could even do things like a design competition. I participated in one of those, and you can set whatever financial limit you want, and you will have to pay the top three suppliers a few dollars to produce something for you. And it's have to follow the fair bidding practices of the region. And that's a good way to get to know the team that you'll actually be working with if you select them. But it's also a good way to weed out the ones that say they can do things and just can't. And you'll get a sense of the quality too. So, and yeah, so that was the procurement phase. And you can break that up into stage gates as well, where you've got a procurement team start up, you design the procurement, you're putting a designed package together. You're not just copying the last 17 that didn't work. And then of course the bid evaluation, which if we do some of the requirements we were mentioning earlier, becomes easier, more defensible, and you can actually put firm numbers to it. It's not just somebody's opinion that, oh, they scored a 5 in that. This is one approach to doing that, where you have a requirement. You either comply, yes, no, partial. If you say no or partial, you have to explain yourself. So that's what that's there for. And a lot of procurements, I think, do something like this, but where they don't go in quite maybe as deep is that, okay, if you're saying it's existing functionality, Well, let's put some numbers to that. So if it's no and there's significant development, that's going to impact the risk figure. If it's yes, it's existing, but it requires configuration. Okay, that's much less worry. If it's yes, but there's no configuration, that's great. It's been out for 5 years. You're not changing code, you're not changing circuits. Everything is, there's good reliability growth on that product. So it exists. So that's very little, there's no development impact. There's maybe a minimal on this. This one's configuration, and this is R&D. You're creating some feature or something that isn't around right now. So you're changing the product. Even if it's claimed to be a COTS product, there's some feature in there that isn't COTS. So don't allow ambiguity. And so yeah, this was just a comparison between acquisition for complex technology versus standard. It's really the difference between a procurement and a purchase order. So complex technology, usually has elements of software, hardware, and firmware on top of other things, and the performance can change significantly between any variants, and the integration and compatibility with the other components becomes higher risk because you've got a lot more interfaces, and you could see, say, 20 or more versions of technology evolve in the background of something like that, where obsolescence and asset management become, significant issues. So this is just, again, hit, really slamming home the idea that it's not a purchase. It's not just a purchase order. You're not purchasing a train control system. It's a procurement. And, there's a lot of other aspects to this that need to be considered. Harmonized risk. Yeah, so we talked about this earlier. I won't go through that again. And so this is versioning, version control, and it just shows you how many, in the life cycle of a high. This was, I think, for a network switch. How many changes would happen to that network switch in the life cycle of the project between notice to proceed and the point where you're actually maybe installing it, and there could be quite a few. So this was a 3-year span that we looked at, where you had all kinds of, you had to rework the spec, you had to change the design, actually had to cancel the PO. This was like a worst case scenario. So it can go through a lot of gyrations, assuming you're tracking it, as opposed to if you have a simple item like a commodity or a material, you might only have 2 revisions. You might have no revisions in 3 years if it's a simple commodity or a material. So don't need to hit that any harder. There were some cost estimates. Oh, this was an example. So if you're just changing the galvanic coating, or you're making the change to the steel and, say, some rebar or some structural steel, you may only have one iteration, and that's what that previous picture was showing. So there's maybe new steel and new coating, so that's not that big of a deal. But then if you have all these revisions to your network switch, which was the example we were using, that's a different approach that's needed, and it builds in a lot of hidden costs that you may not be accounting for. And this was an attempt to kind of capture that, where if you compare that to the previous version of this chart, there's 3,000 hours maybe involved in this, and that was a conservative effort. There's like 29 approval iterations required. So electronic devices are not commodities, at least not when it comes to ARIA. They are maybe when we buy them from Amazon, but if you're procuring one for a transit agency, it's not a commodity, and they could be revised in a huge fashion. So, and I was just mentioning the hidden project costs. Yeah, projects typically have complex requirements that result in suppliers changing their prices. Once contract has been rewarded, uncertainty is a huge issue. So acquirers are considering alternative procurement strategies, which is why this whole thing at APTA was started. And multi-stage procurements is one concept where you do down selects. I think people do versions of this already, probably quite a bit. And you end up with vendors that are sort of the short list, as they call it, and then you can take different actions like with those vendors to kind of sort them out. And we mentioned one of them earlier, where you could potentially do a small rapid prototyping project with all 3 vendors, and use that as a defensible scoring scheme. So yeah, this is just a Gantt view of that, and you can look at it. We're running out of time for my thing though, so I just want to wrap this up and get to William. Um, Everybody's seen this cartoon, I think, in the handbook. And unfortunately, it really does speak the truth to a lot of projects. And there's been some really bad requirements, and that's a whole other discussion, requirements quality. But if you get an RFP and it's got 20,000 requirements, like one I just was looking at earlier, and if it's scoring 1 out of 5, and that's only 5 of the 9 ISO 29148 quality attributes, it's probably actually worse than that. But that's pretty low score for something that was multiple years and multiple millions of dollars was paid for those 20,000 requirements. And why is there 20,000 requirements anyway? That's a whole other question. So won't get into this. This is the Defense Acquisition University chart that you've seen maybe in the handbook, but it doesn't say this upfront stuff isn't cheap. If you're going to do it, you have to spend a certain amount of money. And if you take, say, in our industry, which is, if Mill Aerospace is kind of the 14 or the 12 to 17%, we could probably say that if on a good day we might aspire to be as high as 10, but maybe more realistically 5 or 6%. I don't know. I haven't seen any projects that get anywhere near that level of budget allocation for systems engineering yet. I hope someday we do, but not yet. Yeah, you can't just inspect or audit safety in at the end of the projects. I see that happening even on projects that are live today. And we learned those lessons about quality, or I thought we did back in the 80s. We seem to have forgotten. So we need a second quality revolution. So QA is one of those things that kind of hangs out there and people don't pay a lot of attention to it, unfortunately. But I talked about this earlier. We have to do better. We can't just assume QA is happening. You need to audit it. You need to make sure that somebody is being the process police, and that if we're stating that we're following certain processes, we actually are, because quite frankly, we're being paid to do it. So we should be. Gate reviews, respect the gates. And I think that was the summary. Yeah, this is just a few aspects that I've shown. It's not just purchasing. The foundations for successful procurement, you're laying those in those early gates, which you may not ever get to participate in, or not very frequently. But ideally, at least in the project planning, you are. It makes it harder if you're not, because then the procurement will end up just being fast tracked. It'll be just same as except last time. That's the brainwashing slide. And the mobilization, I'm just gonna I mentioned it quickly, that you've already got stakeholder requirements. At that point, you've got some tool integration and user testing has happened. So people are happy with the tools like the configuration management tool or the change control process, requirements management process. That's all sorted out, and you're training the team as you're mobilizing. You should not be doing that at NTP plus 5 days, because that's too late, and you'll never catch up. And in a lot of cases, you'll just ignore it and move on because the project demands deliverables and payments. So that's that in a short. So we won't do questions and jump right into William. We did the intro, and go, William.
So just a quick time check, Dale. How much time do I have?
Lots. I just did the sort of the 20. Where am I at here? Yeah, I just did. I think I'm only at 20. So you got lots of time.
Okay. Okay. Thanks, Dale. So thanks everybody for making it. Happy to provide a presentation on some of the applications of what Dale mentioned in his procurement process, and especially the early stage gating that's in the procurement process. So for the outline today, looking to give everybody a bit of a context for TransLink in Vancouver and what we're running in the SkyTrain system. Then I'd like to go through 3 case studies with different flavors around what we're delivering at TransLink to highlight some of the concepts that Dale had provided in his presentation, and then a quick summary around what we have learned from our processes. Next slide, please, Dale. Thanks. So to give you a bit of an understanding of what we're doing in TransLink, in systems engineering, my group helps to deliver capital projects mainly for our rail network or rail operator, quote unquote, SkyTrain. On the left, we have the two different types of big projects that we do. Historically, we have focused on state of good repair. So this is looking at technology obsolescence, end of life, things like that. But more recently, with the injection of funding from our senior levels of government, we have been getting involved in a lot of expansion. You'll hear me say this in other presentations. Right now, Vancouver is going through an unprecedented amount of growth. We are building 2 new extensions at the same time, and we are also building a new control center, a new rail yard, and receiving 200 plus cars for the rail fleet. So this is very busy for TransLink. And I think all of this calls for a robust systems approach for our project delivery. What do we deliver at TransLink under systems? We look at a lot of the operational technologies. So we have 4 main program areas highlighted on the right side of this slide: automatic train control, telecommunications, power, and life safety. Next slide, please, Dale. So the context for Vancouver is that we did not start off this way. We didn't actually have a lot of rail. We started in the mid-1980s, and you can see this on the slide on the right. We started very modestly with about 13 miles of a track, just going sort of that dark blue line into the where the fork is almost. And then we slowly expanded through the years, but we have been doing that at a steady pace. And now our system is much larger than it was initially. But what this means is that because of all the expansion and all the upgrades we have made, our system is now very different than what it was initially. This addresses things like technology obsolescence, technology upgrades, and also talks about things like operations and maintenance, because how we operate and maintain the railway is very different in a 66-mile network versus a 13-mile network. So you'll see some of these things come through in our case studies that I'll present forthcoming. Next slide, please, Dale. So first item that I want to raise to the group is is migrating to a new technology for state of good repair reasons. The case study that I've highlighted on this slide is our operational and vehicle radio modernization. So this is a radio that is a technology that we've been largely using since in 1980s, since the original onset of SkyTrain when it was first built. The radio, just like most radios on rail networks, allows field staff to communicate with the control center to allow them to communicate with each other, and also allows us to get train data and emergency information from the field to the control center. As I mentioned, the technology is quite old. We've used this technology since 1986, and again, it was built for a different system. So the amount of information that we pass through, the amount of data and the amount of communications that we were using in 1986 is vastly different than what we're using today. So what we have found is that we have reached our capacity, and we are definitely at the point where we cannot handle additional calls on our radio system, which called for a modernization. Not only was the technology itself, the hardware, getting to a point of obsolescence and not being able to be supported by vendors, the functionality was not fit for purpose. So it was important for us to modernize the radio system to address not only our current network, but also to look at what we're going to be doing for our extensions. And along with that, I think one of the requirements that we've also recognized, it's not just the operational and not just only the technical aspects. There is also a very important customer aspect to this radio system. I think in the days of 1986, there are no such things as cell phones. There is no such thing as Twitter. But now the customer base is now demanding and expecting a lot of these new functionalities to come through in terms of communication and customer experience. So things like real-time information, looking at passenger information displays, those things are now needing to be supported by the radio. So this has now added a different requirement than what we've had before. Next slide, please, Dale. So what did we do? I think this is going to reflect on one of the elements that Dale mentioned around early project planning, making sure that we have a lot of good processes to elicit requirements and to understand exactly what we're trying to build before we start building it. So for this particular project, what we've done was a feasibility study to understand what we wanted to do. Certainly, when we were looking at conceptual requirements, the technology was a very big question, right? So this technology has now sunset. What do we do next? Do we go through a certain type of technology around I guess LTE, or do we want to use other technologies around handheld radios, or do we, that 5G is starting to become a thing? So where do we go? But that was not the only topic for discussion. I think it's very important to recognize that technology is only one component of our procurement process, because as Dale mentioned, there's a number of stakeholders that we need to satisfy. So some of the other considerations you'll see on this slide, operation and maintenance, Dale mentioned a lot about that. Property acquisition, we have to build, potentially we might have to build equipment on new property or existing property. We'll have to think about how we're going to implement and actually install this equipment and test and commission and eventually use it. I think with an operational technology, unlike a piece of infrastructure like a building, or unlike information technology, it's not something you can turn off. So one of the important things to consider in the procurement process is, well, how are we going to operate the new radio at the same time we run the old radio? Because the train needs a radio, right? And you can't just swap them out as you would with let's say a screw or another piece of equipment that might not be so critical to the infrastructure. Integration. This one I think you'll hear from me say a lot. Because integration is now one of the most critical parts of engineering, in my view, mainly because everything is connected together these days. It's very rare that you'll find any piece of equipment, any asset that can stand on its own and without having have some sort of interaction with something else. So, for example, the radio, what else will it need to interact with? On the previous slide, I already mentioned that there are some desires to interact with things like passenger information displays, real-time information. So these are some of the considerations that we'll have to include in our requirements, so that we don't lose them, or we don't prohibit ourselves from being able to deliver this type of functionality in the future. And of course, there's things like cost, commercial, right? There's only so many vendors out there who provide radio systems. Market interest. I mean, how many times do you procure a radio system for a rail system like system in Vancouver? So there's definitely considerations around interest from the vendors as well, and I think Dale mentioned some of that too. And of course, there's industry best practice. What do other people do? What do we want to buy something off the shelf? So a lot of considerations there, and you can see that it's not just about the technology. At the end, 7 options were analyzed, and I'll get to that in a bit, but maybe before that, I'll go to the next slide. The next slide talks a little bit more about the stakeholders, and Dale discussed it quite a bit in his presentation. So again, we did talk to people who would be vested in the technology, but I think it was also important for us to understand all the other players that would need to be involved. So for this particular procurement, what we did was we looked at the technical experts. We also looked at the people who would be helping us do the procurement effort to get their input on what might be the best contracting strategy, the people who would be using this radio. So this would be the people in the control room. This would be the frontline people. And of course, we did some work with our vendors too, just to understand, hey, would you be interested in this? Would this be workable? And then peripherally, we looked at some of our stakeholders from planning, vehicles, and expansion projects, because at some point the radio technology which would touch them in some way. Next slide, please, Dale. So as I mentioned, we had 7 options analyzed, and this is shown here in this matrix. So what we did was we took the 7 options and we put them on the top of the table here. So there's 7 columns. And then we looked at sort of the criteria or the different considerations. Certainly, again, you'll see at the top, you'll see the technology aspects, but then you'll see as we go down through the matrix on the left side, there's other considerations that are not necessarily technology focused. For example, maintenance. For example, integration effort. Schedule. Certainly, I think these are some things that will come up during the course of the project. So it's very important for us to understand how this would work. And not only does it functionally work, but does it meet our stakeholder expectations? Did it make sense with our, I guess, our cost and our budget? So things like that. The other thing to recognize about this chart is that there's no magic solution, right? There is no silver bullet. Everything had every option had some blemish. And I think that's the value in doing this type of analysis early, so that we can understand sort of what are the trade-offs that we need to have with technology procurement. Next slide, please. So what was the outcome? So we chose a new technology for the radio modernization. The legacy radio basically served two functions. It was both the operational radio, so the radio that control center talked with the frontline staff, but also there was a vehicle radio, which was basically sending information from the trains to the control center and the computers. So we decided to split these two elements up. The operational radio would then go on to a P25 technology using local emergency services. Vehicle radio would use the LTE technology, basically mobile telephones, using communication vendors in the local area for that support and assets. The procurement was only the first step. We did take steps to understand concept of operations and maintenance, and understand how we're going to train people. We had to develop new specifications. But I think the important thing is, I think Dale mentioned this as well, we did have a proof of concept to just help people understand what does this actually mean. So this meant we brought in radios to the control operators. We brought in radios for the frontline staff for people to try to put it in their hands and see what it was like. So I think that was very helpful for getting that support to maybe smooth out some wrinkles in the deployment, but also just to build that level of enthusiasm, thinking that so people can actually see, hey, we're getting something new and fancy here. Of course, integration. A lot of this work, we had ongoing integration. It wasn't just done at the project planning phase. Throughout the project, we had to make sure we were engaging other stakeholders from different projects, different interactions, so that they were in step with what we were doing. But ultimately, I think that the last bullet here is actually quite a revelation for us. In the past, we had basically run our own radio for this train system, but through this process, we realized that technology was progressing a lot faster than we can keep up with. Our business was really running trains. We were running the SkyTrain. It was our bread and butter. We felt that it was not appropriate for us to be keeping up with the pace of technology when it comes to radios, or even cellular technology. Just this year, I think my phone switched from LTE to 5G automatically, and that happened so fast that if we had to manage those types of processes, it would have been very difficult for the operators and maintainers. So last slide on the radio. We're at the tail end of the implementation stage. We have cut over in September 2023, and I think it was largely successful. So we're very happy with what happened there. The vehicle radio, we're still in the design phase. Because of the criticality of the radio, we are working through some critical elements such as integration, failover, and safety assurance. But we are expecting to start cutting over on the radio system in the next year or two. But the cutover stage is expected to be quite lengthy, just because we have 200 plus vehicles that we need to swap equipment out, and we have to find the time and the resourcing to do that. But we're excited that we are on our way to getting a new radio system. Okay, so I'll go to the next slide. So that's all for the radio. The next set of slides are going to be on procuring technologies from a sole source supplier. We in Vancouver have a UTO system, GOA4. So basically all our trains are unmanned, and they're fully automated. So that's basically the background for some of these slides here around technology procurement for our vehicle emergency stop system. So because you don't have drivers, these trains have emergency functionality. So if there's an intrusion detected in the guideway, in stations, there is an ability for the system to automatically close a track and stop the trains at an emergency basis. This emergency stop system does use emergency button activations on the platform. So if somebody sees it happening, they can hit the button and stop the train. Same thing like at control, there's emergency stop buttons there. I think the reason why we need this type of technology is that we don't have platform screen doors. That's a different discussion altogether. So if anybody's interested in that, please ping me offline. But like the radio system, the vehicle emergency stop system from 1986 is now obsolete, and we didn't get replacement parts. Spares are no longer available. It's antiquated technology. So a like-for-like replacement is not possible. Next slide, please. Just to give you a sense of why this was more complicated than it looked, it's because we built the system in different phases. So if you remember the first diagram I showed about map and how we built our system from 1986 to the present day, there was a number of different upgrades and different extensions over the years. Well, what has resulted in that is that we have sort of a diverse technology platform for our different systems. So for this diagram, if you look at sort of just the colored dots, you can see that already there's different types of colored dots and different arrangements throughout the system. These colored dots represents the station controller, which is basically for the Expo line, the blue box that controls the vehicle emergency stop system. So the architecture is different, the technologies are different. So we already have some inconsistencies within our network, which makes the procurement a little harder and the integration a little harder just because of the differences. Next slide, please, Dale. So what we wanted to go through in the early procurement phase is we wanted to understand what are we trading off, because there's no perfect solution. Similar with the radio slides, there's no silver bullet. Some of the key things that we went through in this project are listed in this slide. One of the first ones is, do we continue to use a proprietary technology from our sole source supplier? Or do we introduce the market to this and basically open everything up? Second aspect is, do we want to sort of harmonize the equipment so it's much easier to maintain? We only have to have one type of spare. We don't have to be trained on how to use that one type of equipment. Or do you want to basically leapfrog and go to the next, the latest generation of equipment, recognizing that some other parts of the system will have legacy equipment that are sort of in between what we had on the Expo line and what is the latest and the most latest technology that's coming from our sole source supplier. In the orange box here, we also have an item that talks about the vendors. So this is the market consultation. So do we go with a vendor that has experience with our transit agency, our rail network, our context, or do we now open it up and introduce a new vendor who may not have that type of experience? So there's some risk there from a commercial and financial perspective, but also probably some schedule risk because we need to onboard folks to that level of understanding. And of course, there's other confluencing factors that we thought about. So for example, there's maintainability, right? This is a new piece of potentially a new piece of equipment. We have to think about warranties. We have to think about commercial. So I mentioned some of that. How quickly will the equipment become obsolete now? It's important to think about this in this context because I think I mentioned that the equipment that was in service in 1986 has lasted to today, which is about 20 at the time. It was about 2020. But I think we can all relate, technology doesn't last as long as it used to. So think about your washing machine, right? You probably have to replace it every 5 to 10 years. Whereas, I mean, if you kind of like me grew up in the 80s, I mean, my parents bought a washing machine and it kind of lasted me until my late teens. So, we have to think about some of those considerations as well. And of course, integration, interfaces, schedule certainty. So those are some of the other items that we have to think about because here's some background noise.
I heard dog barking.
Yeah.
Can I ask that person to mute?
Wow.
Can someone please help me mute?
Yes.
That is interesting. Wow. Stefan, Shundete, I think you're not muted. Okay. Hello.
Yeah.
Thank you. So as I mentioned, integration, there's obviously elements that we need to interface with, for example, the fire life safety system. We also have to integrate it with our operators and our maintainers to make sure that it's fit for purpose and it's maintainable. So a lot of different elements. What we ended up deciding, and Dale, next slide, please. We decided to used to continue using the proprietary system from Thales to support the renewal of the emergency stop system. So this was the latest, I guess, technology available at the time, the 4th gen STC. We recognize that homogenization. So I talked about having consistency of the equipment. We recognize that that was probably not possible given how big our network had become. It's kind of like, with the Golden Gate Bridge, you finish painting it all at once, or when you finish painting it, and then you basically have to start the next day to start the whole process again. So that's how big our network has become, and because of the need for to do the work only in engineering hours, it was difficult to get that much work done over a period of time. Of course, that commercial, it's a sole source vendor. We have to continue managing the risks, understanding that technology obsolescence will become a factor with the sole source supplier. And of course, concurrent projects. We did look at what other projects were doing. We were looking at TTC Finch West LRT because they were the first agency to put this particular product in service. So we were expecting to see how they were using it, and that would inform some of the decisions we were making from a design perspective. Yes, the 4th gen STC was expected to be in service later in 2020. I think that happened. Next slide, please. So right now for our project in Vancouver, we have gone through the site configuration factory acceptance tests. We want to do as much testing offline as possible so that we wouldn't introduce any bugs in the field, mainly because getting field time is very difficult in an operational railway. I think one of the things that Dale mentioned also was prototyping. So what we're doing right now is we're running shadow mode. We will be starting this, actually, it hasn't started yet. So we're going to be running both the new equipment alongside the old equipment just to make sure that we can see some differences if they occurred, and to help us understand if there's anything we need to be aware of when we put the new equipment into revenue of service. So we do expect this asset to be operational sometime later in 2024, and we're looking forward to getting rid of all our old and antiquated equipment. Okay, so last case study. Thanks, Dale. This is now a new technology. So far, we've been only talking about state of good repair, replacing existing types of equipment. This is a new piece of equipment. This is actually quite rare for what we're using in TransLink, just because we've been running a system for so long. But this is the display management system. The context is we are building a new control center, as I mentioned. It's very exciting. It's our first new control center since 1980s because we have completely outgrown our existing control center. So with all the new lines, with all the new things that are introducing to the system, it was very important for us to now manage all the information that was coming into the control center and to the control operators. We needed a new system that will display the different subsystems in a way that makes sense to the control operators without overwhelming them, and making sure that they can respond adequately to different alarms and different inputs that are coming in from the various field locations. Next slide, please. So because this was such a new technology, we definitely wanted to go through the requirements and concept of operations state to really plan the projects well, to understand what we're wanting to purchase and acquire for the control center. So what we did was we had a lot of engagement with the control center operators and maintenance staff to understand what they actually did. I think we did end up shadowing some of those individuals. So shout out to Dale for mentioning that. Sometimes it's easier just to shadow someone rather than to just to ask them and sit down at a table and list requirements. We also talked through what worked and what didn't work. So current pain points. I think that was very valuable because we're not interested in doing just more of the same if it didn't work. So we had a lot of workshops. We developed different use cases and walked through how people use this equipment. Collaborating with procurement also to understand what is our process for engaging the market, what was suitable, what would be best to mitigate our risks that we saw within the organization. And then, of course, I think, again, to Dale's point around having some pilots, having some technical demonstrations to understand what the look and feel was for the technology. And of course, the last part is identifying and establishing an integrator early in the projects. I think this is one of the biggest things I push for this effort, mainly because this this display management system was going to integrate or interact with pretty much every single subsystem we had in the SkyTrue network. So it's very important for us to make sure that somebody was going to be sitting on top of all this work, making sure that all the bits and bobs connected well with each other, and that we had somebody assigned to help troubleshoot should some interface not work. Next slide, please. So this is a control center mock-up. We did this to help people understand what was it that we're contemplating, help people understand not just from a functional perspective, but from a visual and a look and feel perspective of what they were going to be getting. So I think this was helpful just to ground people in what we're doing. Next slide, please. So right now we have pre-qualified a supplier last year. We have now worked on the procurement of the display management system. So this is done. So they're on board right now, and they're working with our project team. What we're expecting to do is have this display management system to be in service in 2025 and the control center to be in service in 2026. But as a preview to that, what the team has done, I think, is now leverage a lot of the technology that's in place to help people understand better around what this system is doing. So not only do we have that model, we now have a VR model that we've developed, and I think we're showing that off to our control operators this month and next month. So we're going to bring them in and we're going to sit them down, have them try on the VR headset and take a look around. So everything is going to be mocked up in a virtual scale, so that it would help us to pursue that change management, help people provide feedback, but also to get them more comfortable with what we're doing, so that it's a bit more streamlined when we get into service. And of course, this is only the first step. We're getting this display management system to accommodate today's network. But as I mentioned, the 2 new extensions, we've got a new yard coming up, we've got a lot of things on the go with TransLink. So we do expect more modifications and more to be built out on the display management system as the system continues to grow. Okay, so lessons learned. Procurement is not only a technical exercise, definitely multidisciplinary. We're not just buying a piece of equipment. I think Dale mentioned this several times. We are looking to make sure that we satisfy a number of stakeholders. We have to understand the full asset lifecycle. So it's not just getting us across the finish line. And I think you can see that echo through the presentation. And we look at the operators and the maintainers, because they essentially live with this piece of technology for the next 15, 20 years. And understanding how the asset will be operated and maintained, it's important, because we need to tell the vendors what we want to be using the equipment for, because otherwise we're making a lot of assumptions, and of course that usually ends up in bad places. So we need to make sure we understand that, and we elicit those requirements and those desires up front, so everybody's on the same page. We felt that the proof of concept early in the implementation stage was very helpful, just to help people get a look and feel of what it is. Maybe if there's something tangible you can put in your hand, like the radio, I think that just went miles for us to demonstrate what we're actually implementing for the project. Certainly helped with a lot of the change management. Of course, integration, can't forget that. There's a lot of work that we need to make sure to understand how the asset will interface, or the equipment will interface with different aspects of the organization, because I think very much so, this is where projects fail. The integration is where everything falls down. You can have two perfectly good pieces of equipment, but if they don't talk to each other, then there's a problem, or if they don't talk to each other well, right? And we see this over and over again in different projects in the world. And of course, early engagement. Early is definitely better, because then we don't want to forget any. We don't want to forget any requirements. We also don't want to leave anybody out and then cause hurt feelings. So it's very important to make sure we do all that upfront work to put the project in a good state. And I think that's it. Is that it? Yeah.
Yeah, that's yeah.
Okay.
Yep.
Yeah.
That's it. Yeah. And I think
we put this together basically to map it to the map that you had earlier around the different the life cycle. So you can see how our projects, I won't go into this in detail, but you can see how some of the case study elements from my presentation maps to that process that Dale outlined. So it is something that it is practical. It is something that we are doing, and these are just examples of how I can map it. But ideally, we would basically walk through every project in this way to map it to the different procurement stages, the design phases, the implementation, so that there is a robust way of managing progress, but also managing expectations. Okay, back to you, Dale.
Great, thanks, William. Yeah, just quick. there's two things. One is we're running a bit late, but also there was an error in the flyer, and this was supposed to be a 90-minute session, so I hope people can stay. Um, Apologies for that. I just realized when I was looking at the flyer. But anyway, let's get right into it with Bill. Is Bill on? I can't see who's on and who isn't on, but
I
Let's
can't
see.
see Bill unless he's under a
No.
different name.
Yeah,
oh,
Bill's not on there.
oh, okay. Well, I guess that being the case, we'll try to catch him another time. And what we'll do is just open it up for questions for those folks that have stayed along. And again, I apologize for the mistake in the flyer, but we'll open it up to questions, please.
See some comments in the chat. Is that
Oh, okay.
where
Yeah,
you want to
I'll
go?
just stop sharing for a second, then we can, yeah, that sounds good. Stop share and open up the chat if I can find it. Just people dropping on and off. Oh, we had people on from Australia. Yeah, so I don't see any questions, just a back and forth on what a ConOps does. Any other thoughts from anybody on the line, or and what I'll do is I'll stop the recording now too, so that nobody feels they're asking questions that they don't want recorded or anything like that. So I'll stop that. Yes.